Okay, let R be the region bounded by the graph y equals x squared and the y equals 4. Find the area of the region R, where R is the base of the solid. For this solid, each cross-section is perpendicular to the y-axis. Ooh. Usually things are perpendicular to the x-axis when we do this, but they made it to the y. That's evil. Is an isosceles triangle whose base is in the xy plane and whose height is twice its base. Ew. Okay, that's all right. Find the volume of the solid. Okay. So, I like to draw these things in like 3 dimensions, Bob, just to, you know, I don't know, it kind of helps me to see, right? Okay.
Yeah.
So it's bounded by the line y equals 4, right? So that's 1. I'm gonna really try to draw my diagonals here. It's very quirky, but okay, cool. Y equals 4. All right, so we know this is a line, right? This is y equals 4. And the graph y equals x squared. Okay, so y equals x squared, right, is gonna look like kind of like a U, right? So that's gonna do something. Yeah, I'm trying to think. That'll do something like this, right?
Mm-hmm.
Okay, good. And then what they say is that we want to find the area of the region where R is the base of the solid. So this whole thing here, this is R. That's the base of our solid. And what we're building are, they say here, triangles, right? Isosceles triangles specifically, right? Where this is the base, right? And then they go up with, I believe, something where, like, what do they say? The height is twice the base? Yeah, height is twice the base. So here's an example of, like, some of the triangles that would get built. My art skills are on point today, dude.
Wait, sorry, is the height like from the middle?
Yeah, good. Yeah. Actually, let me just draw 2 triangles. That's it. I start getting over. It's gonna get complicated. Yeah, they're saying this right here. This is the height, right? And we're saying that the height is equal to 2 times the base. Okay.
Mm-hmm.
All right. So, the key thing here is that we're going to be adding up a lot of these triangles, right? So what I like to always do first is figure out, like, what is an expression for the area of each one of these triangles, right? The area of a triangle, right? What is the general equation for the area of a triangle?
1/2 base times height.
Good. 1/2 base times height. Okay, we know that's equal to A, right? And then there's a key thing here, right? They tell me that the height is already twice the base, right?
Yeah.
So I can just plug that in. We want to try to get rid of as many variables as possible. We always want to, like, try and get things to relate to, like, just one thing. So I'm just going to...
just B squared.
Good. It would be what?
B squared.
Yeah. Good. Yeah. So I'm going to take this into here, right? And that's going to turn this whole thing into, BH squared, right? Or sorry, B squared. B squared, right? Because the 2, it's 2 times the 1/2 and B times B. All right? Cool. Area of the triangle is equal to B squared. All right. So what I'm going to do is I'm going to add up a bunch of these triangles, and, like, which direction are we adding up all the triangles?
dy.
Good. Yeah. So we're going in this direction. This is why this is dy. So I'm going to write this as the integral, right? And then what y value are we starting at, and what y value are we ending at?
0 to 4.
Good. 0 to 4. And then I need the area of the triangle, which we're going to say is equal to B squared for now, okay? And then it's going to be times dy, right? Because dy is like adding up, like, this, it's like the thickness of this triangle, but then we're doing it amongst, like, a million of them, like, just going all the way out to y equals 4. Okay?
Yeah.
Now, the issue with doing this integral so far is that b is not y. You can only do integrals that have variables that share the same variable with the d whatever, okay? So I need to find a way to express what the base is of each triangle in terms of y, okay? Which that can sometimes get hard. How do you think we do that, Bob?
It's going to be 4 minus square root of y.
Okay, let's see. So the base, right? The base is gonna be this amount, right? Times 2. Okay. Do we see that so far, Bob? Like the triangle base is this and this, right?
Yeah.
Okay. So this is, for instance, this is the x coordinate, right? Of this line, right? And then we need 2 times that, right? So the base is equal to 2 times, I say, the x coordinate, okay? Of this line, all right? What is the x coordinate of this line that's like that's controlling the thing? That's like bounding it, I guess. Yeah.
X squared.
So it's y equals x squared, right? So if I want to solve for what the x coordinate is, what would that be?
Square root of y.
Good. Square root both sides. You get x is equal to the square root of y, and now I can plug that into here, okay? So now I get this is equal to b squared, which is 2 square root of y, right? That's b, 2 times the x coordinate, right? All that squared, which is now going to equal 4y, right? Now I'm going to get rid of this, right? Because instead of b squared, I'm going to write 4y. And now this is like the simplest integral in the land of calculus, right? How do we do this one?
4y squared over 2.
Good. And we integrate from 0 to 4, right? So now you just plug in 4 for that, right? This simplifies to 2. So it's 2 times 4 squared minus 2 times 0. So you get the answer is 32. Okay, and then did they tell you the units? No, they just said 32. So 32, and then you want to put units squared. Cool? Or units cubed. Almost got that wrong. Yes. There we go. Yeah, units cubed.
Wait, what would be a difference if I... Because if it said by the x-axis, I see a difference. Never mind.
Yeah, so the x-axis would be tricky because then you would have to be making the triangles this way, right? Which, now your base would be 4, right? It's 4 minus whatever the y value is of this, right? Do you see how this, right? That's why that would be 4 minus x squared. That would be your base, and then you would square that, right, to get the 1/2 base. Yes, good, awesome, dude. Yeah, cool. That's a very good question. I like that. Yeah, and the important thing here at the end is like because this is a volume, everything's cubed. It's like units cubed and whatnot. Cubes or volumes. Okay, awesome, great, cool, great question, Bob. That was dope. I liked that one. All right, let's do the giveaway.